we move forward. Section 2.3. Oh, in about 40 minutes. They're there. They're graded. I have them done.
How were they?
The test was great. Some of the answers were a little questionable, but the test was great. One of the best I've ever written. The test was okay. We'll talk about it. Just best. It's one of my favorite ones. It certainly wasn't one of the hardest ones I've ever given. But it wasn't one of the easiest ones either. All right, section 2.3. Product rule and quotient rule. If you wish to do well in this class, section 2.3 and 2.4 are probably the two single most important sections in the class, which sounds kind of weird, the two single most important sections. That doesn't sound right. The next two sections are very, very important because for about the next month and a half, we are going to study derivatives. So no matter what I ask you, the right answer from now on will almost always be take the derivative. And if you cannot take the derivative correctly, you can't do anything else after that. And these two rules, today we'll do product rule and quotient rule. On Monday we'll do something called the chain rule. And we will use those three rules almost every day for the rest of the semester. So if you don't know those three rules, and if you can't use those three rules, you're finished. You just can't do anything correct after that. Okay, so the product rule looks kind of like this. The other day we had a problem, something like this. F of x equals 2x minus 5 times 3x plus 1. And we wanted to take the derivative of that thing. And we said, well, we can't right away because right now we have multiplication involved. We have something that has an x times an x, and we don't have any multiplication rules. So what did we have to do the other day when we wanted to take the derivative? We had to do some algebra. We had to do FOIL and expand it out. So we FOILed it out. We wrote it as 6x squared plus 2x minus 15x minus 5, which turns out to be 6x squared minus 13x minus 5. So that's what we had to do. That was our only choice. Now we have it written in a form where we can take the derivative. So now we write the derivative. We write our derivative symbol. The derivative is 12x minus 13. All right, well, that's great. I mean, we can do that. It works out. But the problem we run into is, what if I give you a function like that? G of x is x squared sine x. Unfortunately, there's really no algebra you can do with that. You can't FOIL it out and write it into a form where you can take the derivative. So we need a rule. We need a rule that tells us, what do you do when you have multiplication? What do you do? Any guesses?
I want to say to take the derivative of the first one multiplied by the second one plus the derivative of the second one times the first one?
That is absolutely correct. And what he just quoted is what's known as the product rule. All right, so the first thing I want to show you is, go back to this problem for a minute. F of x equals 2x minus 5 times 3x plus 1. The derivative, this does not work. This is what a lot of people guess you should do. A lot of people guess, well, take the derivative of the first one. Take the derivative of 2x minus 5. What's the derivative of 2x minus 5? 2. And then just multiply it by the derivative of the second one. What's the derivative of the second one? 3. 2 times 3 is 6. Is that the right answer? No. Is it even close to the right answer? Is it close? 6 is close to 12x minus 13? I don't agree that they're even close.
If you took it and multiplied it by 2x
minus 13 over 6, then you do happen to get the right answer. Correct, but I don't think that's a good rule to try to deal with. All right, so unfortunately it's not that simple. You don't just get to take the derivative of the first one and the derivative of the second one and multiply them together. That just doesn't work, unfortunately. All right, so here is the rule. I'm going to write it down and then I'm going to prove it. If h of x is a product of functions, f of x times g of x, then the derivative is f prime, h prime of x. What you do is you leave the first one alone, and you take the derivative of the second one. And then you add, and you switch them around. You take the derivative of the first one, and you leave the second one alone. Now, the nice thing about the product rule is you're going to notice that everything is addition and multiplication. So the order doesn't matter. That's correct. So I could just as well write this as I could take the derivative of the first one and leave the second one alone, and then add and leave the first one alone and take the derivative of the second one. I can switch order on the plus sign because addition is commutative. By the same token, I could also switch order on all the multiplications, couldn't I? If I wanted to. I'm not going to, but I could. So there are lots of different ways to write this. The basic rule is you take the derivative of one, leave the other one alone, and then flip it. Take the derivative of the one you didn't before, and then leave the other one alone again. All right, so let's just try that for this function f of x here. F of x is 2x minus 5 times 3x plus 1. So according to the product rule, the derivative would be, I leave the first one alone. So I just write down 2x minus 5. I don't do anything to it at all. And then I take the derivative of the second one. What's the derivative of the second one? 3. Plus, and then I switch it around. So I leave the second one alone. I leave the 3x plus 1 alone. And then I take the derivative of the first one, which is 2. And now we need to convince ourselves that that really is 12x minus 13. It better be the same answer we got before, or the teacher told you something very wrong. Let's see what we get here. We get 6x minus 15 plus 6x plus 2. And I wasn't lying to you. It does work out, 12x minus 13. Questions on that? All right, in this class, I don't prove a lot of theorems, but this is one that I do like to prove. I do like to prove the product rule here, and there's a good reason, and I'll show you in a second. So, we're going to let h of x equal f of x times g of x. Then, by the definition, the derivative would be the limit, as h goes to 0, of f of x plus h times g of x plus h minus f of x times g of x all over h. Okay, so that's our typical definition where we replace x by x plus h, and then we have the original functions, and then we divide by h. All right, now here's what you have to do with this one. I'm going to rewrite this way. This is the limit as h goes to 0. F of x plus h times g of x plus h minus f of x plus h times g of x plus f of x plus h times g of x minus f of x g of x. Kind of ran out of room there. All over h. Why this is so dull today? That's an excellent question. That's what I was going to ask. What in the world did I just do? I made it a bigger, longer mess. I did that. What did I do? Can anybody tell me? I added 2 middle terms. So this term right here is new. And that one right there is new, isn't it? So I put in 2 new things right in the middle there. But what can you tell me about those 2 things? They cancel out, they add to 0. So what did I do? I added 0, but I wrote 0 in a really funny way. That's all I did, correct?
Oh, you're going to use that as like a completing the square kind.
It's similar to a completing the square kind of thing, that's correct. I added 0, but I wrote 0 in a funny way. And that's a common technique in a lot of math proofs. You add 0, you just have to add it the right way. Kind of funny looking. All right, so now what I'm going to do is I'm going to split my fraction. So I'm going to split my fraction I'm going to put these two things together. Consider them as one piece. And then these two things together, consider them as a second piece. Looking at the first piece here, I can factor something out. What can I factor out? Factor out an f of x plus h. So I'm going to do that. I'm going to flip the page here. So I'm going to have the limit as h goes to 0. I can factor out the f of x plus h. And when I factor that out, what am I left with? I think, I'd have to go back and look, but I think there's a g of x plus h minus g of x. And of course, the whole thing is over h. Is that correct? Let's go back and look. Find the right page here. So if I factor out this f of x plus h, I have a g of x plus h minus g of x all over h. That's correct. Okay? Second piece. What can I factor out of the second piece? I can factor a g of x out, and what am I going to have left? F of x plus h minus f of x all over h. All right, so let's write that down. So plus, I can factor what did we say, a g of x out? And then we have left over f of x plus h minus f of x over h. I'm off the screen. There you go. Better? All right. We're almost done. In fact, this is our last step. When h goes to 0, what's f of x plus h? Can you plug 0 into that? Yeah, and you get f of x. So there's f of x. When h goes to 0, what's this thing? By definition, that's the derivative of g, isn't it? The derivative of g is the limit as h goes to 0, g of x plus h minus g of x all over h. So we have the first two pieces become f of x, g prime of x. So I leave the first one alone, I take the derivative of the second one. Plus, and then over here, now I'm going to leave the g of x alone. And same thing, what happens when h goes to 0? When h goes to 0, by definition, that thing is the derivative. So there's the proof of the product rule.
Are we going to memorize that?
Do you need to memorize the proof of the product rule? Absolutely not.
I was going to say, if we had to ever do that.
You will never have to do that again in this class.
Wait. You specified this class. Why?
Why? Because my guess is if you go on further in math and you take a course such as, it's called maybe advanced calculus or probably algebra 1, or I'm sorry, analysis 1, my guess is you will be forced to reproduce that proof. That's my guess. I had to do when I took those classes, so you should have to do it too. But you won't take those classes here. We don't offer those classes. You'll take those classes at your four-year institution. All right, so all you're going to have to do, you need to know how to use the product rule and get the right answer. All right, so back to the question I had a minute ago there. Well, why the lighting on this is so bad today? What's bothering me? A minute ago, I had something like g of x is x squared sine x. The first thing you need to recognize is if you go to take the derivative of this, you do need to use the product rule. What tells you that you do need the product rule? Things are being multiplied. Not only things are being multiplied, but both the things have an x in them. If one of them didn't have an x, you wouldn't need the product rule. I'll show you what I mean in a minute. But we have x squared times sine x. They both have an x in them. So our answer is going to be g prime of x is. I leave the first one alone. That's x squared. I take the derivative of the second. What's the derivative of sine? Cosine. So cosine x. Plus. Now I leave the first one alone. I leave the second one alone. That's sine x. And I take the derivative of the first one. The derivative of x squared is 2x. As far as I'm concerned, you can leave it just like that. Could you simplify? I suppose you could factor an x out. There's an x here and an x there. You could factor an x out, but you don't have to. Leave it just like that for now. All right, how about this one? H of x is 36x to the fifth. I have multiplication there. I have 36 times x to the fifth. Do I need to use the product rule? No, why not? This one's just a number. This one's just 36. There's no number in that one. It's just 36 times x to the fifth. So our derivative should be h prime of x is the 36 just stays, and then I take the derivative of x to the fifth. I get 5x to the fourth. So that's a problem I will see students use the product rule on. Do you need to use the product rule? No. Will the product rule give you the right answer? It will, actually. Do the product rule. The product rule says, leave the first one alone, that's 36. Take the derivative of the second one, that's 5x to the fourth. Plus, now I leave the second one alone, that's x to the fifth. And I multiply by the derivative of the first one. What's the derivative of 36? 0. So will the product rule give you the right answer? Yeah, sure it does. But there's no point in it. That's correct. When do you need to use the product rule? When you're multiplying two variables. That's right. If you have a number in a variable, you do not need to use the product rule. Okay? Although it does work. If you want to do extra work for yourself, you can. Have fun. It'll work. It does take longer. I agree with that. All right, let's do one more with the product rule, and then we'll talk about the quotient rule. So let's see. F of x is, how about, I don't know. Anybody got a good product? 5x squared plus 2x times 6 cosine x. All right, well, my derivative would be f prime of x is. I leave the first one alone. That's 5x squared plus 2x, bless you. Times, I take the derivative of the second one. What's the derivative of 6 cosine x? Not negative 6 cosine x, negative 6 sine x. Good. Negative 6 sine x plus, and then I switch it. I leave the second one alone. 6 cosine x. And I take the derivative of the first one, which is 10x plus 2. Questions on that one? I lied. I said we were going to do one more product rule. I'm going to do one more after that. Last product rule problem. H of x is x to the fourth times sine x times cosine x. What's the problem with this one? There are more than two things being multiplied together. Our product rule only works for two. What do you do if you have 3 or 4 or 5 things multiplied together?
Take the product rule of the two of them, and then take that product and multiply it, use the product rule again, and the third.
Correct. That would work. And here's essentially what happens. When you have 3 things or 4 things or 5 things, what you do is you take the derivative of one of them, and then what do you do with the other ones? Leave them alone. And then plus, you take the derivative of the next one, and what do you do with the other 2? Leave them alone. Plus, you take the derivative of the last one, and then leave the others all alone. And that's essentially what would happen if you did what you just said. Take the product rule using 2 of them, leave the third one alone, and then do the derivative of the third one. All right, so not as hard as it looks. H prime of x is, I take the derivative of the first one. That's 4x cubed. I leave sine x alone. I leave cosine x alone. Plus, then I take the derivative of sine. What's the derivative of sine? Cosine x. And I leave the other 2 alone. That's x to the fourth cosine x. Plus, and then I haven't taken the derivative of cosine yet, so I do the cosine one. What's the derivative of cosine? Negative sine. And then I leave the other 2 alone, x to the fourth sine x. So that's all there is to it. If there's more than 2 pieces, take the derivative of one, leave the others alone, plus, and just keep going.
Is it okay to leave it in this form as well?
Absolutely. And this one you could simplify a little bit. I mean, it would be nice, I suppose, if we wrote cosine times cosine is cosine squared, and sine times sine is sine squared. Be nice if we did that, I suppose. And if we really wanted to get fancy, I guess we could factor an x cubed out of everything. At this point, I don't care if you simplify or not. Leave it like that. Okay, along with the quotient rule, along with the product rule, we also have a quotient rule. The quotient rule tells you how to handle fractions. The quotient rule says if h of x equals f of x over g of x, so this time you have a fraction, then h prime of x is, you leave the bottom alone, you take the derivative of the top, minus, you switch it, you leave the top alone, you take the derivative of the bottom, divided by the bottom squared. No, I had made a mistake. I was putting my square there, and then I realized that was in the wrong spot. It's just the bottom, whole thing squared. It's just g of x. Now this one, unfortunately, has a minus sign in the middle. So what does that mean? It means subtract. It means you can't switch the order. Okay, you can switch the order here if you want. You can write this as derivative of the top times the bottom. And you can switch order on the multiply over here, but you've got to get them in the right order for the subtraction. It's got to be leave the bottom alone, take the derivative of the top, minus, and then flip it. Okay, so that one you do have to get in the right order. The product rule, you can be willy-nilly with the order, put it any way you want, and you'll get the right answer. Quotient rule, that's not true. You've got to have it in the right order because of that subtraction sign. Okay? When I was in calculus, several years ago, here's what my teacher told us. If f of x is high over ho, then the derivative is ho d high. Where what does d stand for? Ho d high. Derivative. Minus high d ho. Over ho ho. That's what my teacher told me many, many, many years ago when I took calculus. When did I take calculus? Before most of you were born, probably. Anyway, that's what my teacher told me, and it always kind of stuck with me. Ho de high minus high de ho over ho ho. Figure out a way that you remember it. The important thing is leave the bottom alone first. I think if you remember that much, leave the bottom alone and then work from there, you'll usually get it in the right order. Okay, so these look like this. Once you know the rule, it's no big surprise. F of x is x squared minus 3 over 4x plus 5. So we recognize right away that we have a fraction. When we recognize right away we have a fraction, we guess we're probably going to use which rule? The fraction rule, the quotient rule. So our answer is, the derivative would be, we start with the bottom, that's 4x plus 5. We take the derivative of the top, 2x, minus, then we leave the top alone, x squared minus 3. We take the derivative of the bottom, 4, all divided by the bottom squared, 4x plus 5, whole thing squared. And again, as far as I'm concerned at this point in your life, you can leave it just like that. You could simplify this one. You could, distribute the 2x through, distribute the 4 through, combine your like terms, simplify if you want to. If you're doing your homework and you're checking the answer in the back of the book, they're going to be simplified, but not terribly difficult at that point. Distribute, combine your like terms. Questions on that? All right. How about g of x is, I don't know, what do you want g of x to be? Give me a nice fraction function. 2x squared over x to the fourth. That's a good one. All right, so we take the derivative. G prime of x is the bottom is x to the fourth times the derivative of the top. The derivative of the top is 4x minus the top, that's 2x squared. The derivative of the bottom is 4x cubed, all divided by x to the fourth squared, which is a fancy way of saying x to the eighth. You multiply those powers, x to the eighth. Perfectly correct answer. But I don't like it very much. I'm going to give you a better answer. You can take out a lot of x's, you can do a lot of factoring and reducing. Or, if you're clever, you reduce right from the beginning. What's 2x squared divided by x to the fourth? That's 2 over x squared. And 2 over x squared I could write as 2x to the negative 2, couldn't I? Do I need to use the quotient rule? I don't need to use the quotient rule at all for this problem. A better answer is g prime of x is negative 4x to the negative 3. I like that answer a lot better. Looks much less complicated. Okay, so that's something you need to watch for. Yes?
Now, on a test or quiz, you accept either answer.
Absolutely, they're both correct. I would accept either answer. Although I would be more happy with one than I would the other, but I would accept either one because they are both correct. So, just because you have a fraction does not always mean you need to use the quotient rule. And that's something to watch for. When will you need to use the quotient rule? When will you not need to use the quotient rule? Let's do that one. When do you not need the quotient rule? When you can simplify. So this first problem we did, x squared minus 3 over 4x plus 5, there's no way, well, we could do long division on that, I suppose, but it's not really going to help. You can't simplify and reduce. On this problem, you're able to simplify and reduce, you're able to get it so that you have just a number on top. When you have just a number on top, you can bring the thing up to the bottom, and then you don't need the quotient rule. So it's kind of like, I'll see this a lot of times, I'll give h of x is 14 over x to the fifth. I will see people use the quotient rule on this problem. Will the quotient rule give you the right answer? Yes, absolutely. It's a quotient. The quotient rule will always give you the right answer. It's just that it's the hard way to do it. What's the easy way to find the derivative? Write that as 14x to the negative 5.